Hello, I hope you understood my previous examples on SSC and SSCXE. So today in this class, so I'll be taking you guys to the next case study where the arithmetic expression has the different operations. Okay, so that is where the case 4 I'm in the expressions I'm taking up in the today's example, right? For which let us generate. This is what the problem statement, right? So now let us generate the programs in SAC and also SACXE. So again, same way, like if I mean to say that different, if I say that a different kind of operations, so you'll have to understand one thing is for sure that whenever the expression is given, you can't maintain. I mean, say there will be the scenario where you need to maintain the associativity and the precedence of the operators. I hope you know that. So that is what we are going to take up in the today's lecture. So here, okay. Yeah. So if you ask me what kind of example which I am trying to talk, convey to you guys in the sense, suppose if you have it is m is equal to, you have an expression called as say for example p plus 6 and star q minus 5. So I repeat here it is p plus 6 minus q minus 5. So even for your understanding, I can also directly take this constant values itself so that you can understand better, right? So I'll say that 4 plus 6 my star, I get the 7 minus 5. So whenever the expression is given like this, so you can observe, yes, the expression contains only the constant values. It doesn't have any variable operands, fine. So you can directly get the value what need to be loaded to the m register, variable m. That's true, but what I am trying to highlight in this example compared to my previous examples, that so you need to bother about the associativity and precedence of the particular operators, because you can't directly take up. However, we have taken in the previous example, like you take from the left side operand and you keep performing the operation, right? Here you should not do that. Here you can't say that 4 plus 6 first, then 6 minus 6 star 7. No. You can't apply first plus then. I hope you are understanding my point. So how to tackle that? That's what we are going to see in the today's lecture. Right. So as usual, I'll just consider first let us write the SIC SICXE program. Later I'll take you to the first I'll write the SIC program. Later I'll take you to the SIC SICXE as well. So as however, first let us declare the different constant values. So I hope you can see constant. There are 4 constants here. I'll say constant 1 with the word, and what is that constant? It is a 4. Then I have constant 2. What is that value? It is the word 6, then followed by constant 3, which is word 7. It is word 7. Then you have constant 4. So like that, there are 4 constants you can observe. So wherein I just initialize the 4 constants. Then later I need to declare the I need to declare the variable as well. So which is I need to allocate the memory space. I'm just allocating 1 word of memory space, right? So if you ask me to start the process right now, so how do we do, my dear students? So initially, as I mentioned right here in this particular scenario, I understand, my dear students. So you should never directly take you to the here. You should not directly go with the process of 4 plus 6 first. Okay, you should not go for the 4 plus 6. You should do what 6 star 7 first, then you should go with the 4 plus operator and the minus, because a star has the highest precedence compared to the minus and the plus. In that perspective, first you have to complete the star, right? So if you have to complete the star first, in the sense you have to load 6 first. You have to take up this 6 star 7. I repeat, first you have to complete the star. So you have to take up the operation which is between the 6 star 7. So in that perspective, what I am going to do, it is I'll say LDA 6. Where is that 6? 6 is in the constant 2. I'll say constant 2. So what we did, A is 6 is being loaded to the accumulator register. Now I'll be doing mul. Okay, I'll be doing mul with what? With the 7. Where is the 7? It is with the constant 3. So what we did, so right now A is constant 2 is pushed to the accumulator register. With that you multiply with the constant 3. So what it has become? It has become 6 star 7. Right? It has become 6 star 7. Where is the result? It is still in the accumulator. Remember, the result is still in the accumulator register. My dear students, remember, the result is still in the accumulator register. Then later, once after you got to know that yes, result is still in the accumulator register, then later you can perform the, so with that you can add a plus 4 because it is the addition with the 4. So I can directly say that add 4. Where is the 4? It is in the constant const 1, constant 1, and with that whatever you get the total final result, with that you can subtract with the 5. So I'll say that sub 5. Where is that 5? It is in the constant 4. Constant 4, right? So that's how we did all the operations. First we have taken 6 star 7, then with that we will be added with the 4 and subtracted with the 5, right? And still the resulted in the accumulator register. So that I'll be pushing onto the M, right? So in this example I'm not showing anything diagrammatically because I have already shown in the previous examples as well. So here I'm directly taking with the programs instead of showing you any kind of diagrammatic. So I hope if you understood my previous examples, so it will be easy for you to understand this as well. And with that you can have any start and end instruction with any address, okay, starting address, right? This is what the programming SIC, right? So if you ask me how to generate in SIC SICXE as well, right? So as a waiver, we know that here it has a 4 constant values. Those constant values you don't have to declare in SIC SICXE. It can be directly used. It can be directly used in the with the help of registers. I go on to the SIC SICXE. If you ever ask me how we did, in the sense, first we have completed the 6 stars. So by using this. Okay, so here what we are doing in the sense, we are pushing the accumulator register to the accumulator register. You are pushing what? You are pushing the 6, right? That's what you did. So in the next next what you did, so here we are pushing 6. Then next in the next line what you are doing, you are multiplying that. Okay, that for that you will be multiplying with the 6 star 7. 7 is multiplied, is it not? So then in the next line, what you did in the next line, with that you are adding that. So it is the same as, for that only you are adding. Is it clear? Again finally for that only you are subtracting. So it is the same as the original expression. And final result whatever you get, okay, final result whatever you are getting, that it is still in the accumulator register, so that you are pushing as m is equal to a. This is what has happened in the SIC program. Right now I will be taking you to the SIC SICXE as well. As I mentioned, the constant values can be directly utilized in your register. So I may not be using the temporary memory spaces right here. Okay, I can make use of them directly. So how I'll be using, in the sense, for your understanding, you can observe, my dear students. I'll say that LDS LDS I can say 4. I can say LDS hash 4, not the simple 4. LDS hash 4 immediate addressing mode. Then next I can say LDT 6. If not, for your understanding, I'll say LDT 7. Okay, then LDA hash 6. Now if you see here what has happened, okay, you can also do variations in utilization of registers. It's not that you have to use in this way itself. Okay, don't ever have in that scenario, right? So what we did, in the sense, 4 is stored to S, 7 is stored to the T, 6 is stored to the A. We are using only the register. We are not using any memory spaces. So that's where you can increase the that's where you can decrease the CPU cycle utilization, right? Okay, now let me directly take you to the direct operation of multiplication. So I'll say that mul r between what? Between 6 and 7. Where is 6? You have A. So 6 is in the A, and 7. Where is the 7? 7 is in the T. So I'll say that A comma T. So mul r A comma T, right? Still the resultant. Where is the resultant? T. Resultant is in the T. For that you have to. So I'll just say that add R, right? Where is the 4? 4 is in the S. So I'll say that S comma T. Are you getting this? So I'll say that S, which is 4, will be added with the T. So still the resultant is in the T itself. Now I need to subtract with the 5, right? So what I'm going to do, anyhow, where is the resultant? Resultant is in the T, right? So you can update the value of A and the S. So that's what I'm going to do right now. LDA hash 5. And now I'll be subtracting sub R between what? Between the T and the A. And the resultant is still in the A, so that I'll be pushing by using STA to the M. That's it. So that's the program for you, wherein this is the SIC SICXE program for the given expression. expression which has the different kind of operations, different kind of operators with a different precedence, right? In the next lecture, in my next video, I'll be showing you how, if it has a braces, how it has to tackle. Okay, thank you.